The views expressed on Science for the People are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
This week on Science for the People, we're looking at what happens when government-funded research falls victim to budget shenanigans. Hello and welcome to Science for the People. I'm Desiree Schell. Just after midnight on the morning of October 17th of 2013, the budget standoff between President Barack Obama and the United States House of Representatives finally came to an end. President Obama signed legislation funding the government until January 15th, and most federal employees were back at work that same morning. Thousands of government workers were furloughed during the impasse, and ongoing projects languished without funding. And this week, we're going to spend the hour discussing the fallout of the shutdown and the lingering effects it's having on vital research projects. My first guest today is Dr. Andrew Rosenberg. Andrew is the director of the Center for Science and Democracy at the Union of Concerned Scientists. He's served on multiple federal scientific advisory bodies and is a professor of natural resources and the environment at the University of New Hampshire. Wonderful to have you here, Andrew.
Thank you very much for having me.
Now, you wrote an article on scientificamerican.com titled, "The Government Shutdown Was Temporary, Its Damage to Science Permanent." So could you walk me through what happened immediately after word came down that the government was shut down?
Well, of course, the U.S. government decided that some employees were essential, but most federal employees were considered non-essential and were sent home. And that meant that federal employees had to shut down their computers, stay off of email, were not allowed to come into work, were not allowed to work on whatever their tasks were, their projects, couldn't use government facilities. Now, in addition, it meant that they could not connect to all of the people that scientists normally talk to. So they couldn't connect to colleagues or grantees or contractors or even students that might be funded on federal grants in universities all around the country. So effectively, you halted a big piece of the science enterprise of the United States and said, this fraction, which is quite large, can't participate until Congress authorizes them to go back to work. A few people who were considered essential employees were required to continue to work without any guarantee of being paid. So they were effectively required to volunteer their time. Ultimately, all federal employees will receive back pay. So in the end, they will be paid for the time that they were not allowed to work and not allowed to do the work that they wanted to do as scientists. So in budgetary sense, it's a little hard to see how that fits together, but that's in fact what occurred.
So then you're saying that basically scientific research was impacted almost immediately.
Union of Concerned Scientists has a scientist network of 20,000 members who have said, we want to work with you on public policy issues. One of my staff suggested that we ask the network immediately how they were being impacted. And we very quickly started to get response from our network members. And that included people who, had spent a year or more setting up a specific experiment with the James Webb Telescope. This was an example that had people flying in from all around the world to do a specific set of instrument tests. And then the shutdown happened, and they had to go in and say, I'm sorry, this facility is closed. Thank you very much for flying from wherever you flew in from Europe, from Asia. We cannot conduct this test. I'm not allowed to be here. And we just hope that the equipment isn't damaged because we can't, ensure that, some instruments need to be kept in very specific conditions, can be maintained securely. So there were those immediate impacts without question. And of course, every scientist knows that itself has a long-term effect. You don't test an instrument for a space telescope that's going to be flying years from now. You have to catch up because everything's on a very tight schedule. You can't guarantee that you could bring in those 50 partners from around the world at any other time to do these tests. So that may have a long-term impact on the capabilities of the instrument.
But let's talk about some of the specific programs because you've been watching them. Your piece is vaguely terrifying, and I think a lot of people aren't quite clear as to what was affected. For example, safety inspections.
Consumer product safety inspections, in many cases for imports and exports, for that matter, were effectively halted, and that either meant that the products didn't move or the products moved without inspection. Food inspections did proceed because most of the employees were classified as essential, but even so, because they didn't have back office help, there was a reduction in even things like food inspections. So those are the kinds of technical tasks that we rely on. But frankly, most people, unless you're in the field, a particular field, they just expect that somebody's checking to make sure that the food is safe, or children's clothing or children's toys are safe. It's not very apparent to the public that all of these things happen and that the federal government both funds and manages that process, but of course it does.
Since you mentioned the federal agencies, the Environmental Protection Agency, you wrote about one of those scientists.
The Environmental Protection Agency, of course, has a very broad mandate of monitoring and evaluation for a huge range of environmental issues. And they effectively sent, I think, something like 80 to 90% of their employees home. So all of those analyses effectively stopped. The same thing happened for other agencies. Inspection for plant pathogens stopped. And we had plant pathologists write in and say, I was classified as non-essential young researcher. I investigate crop pests. I'm looking for outbreaks. Congress considers that non-essential. Why don't you ask the farmers who are relying on me to make sure that there isn't an outbreak that can wipe out their crop? All of those things stopped. Now, I'm not aware that there was such an outbreak, but you're raising the risk factor by sending people home.
And there was another example that I wanted to point out. The federal wildlife biologist had to suspend capturing endangered gray wolves.
This is an interesting situation. I mean, wolves are an endangered species. They've been under a recovery plan for quite some time. There's quite a big dispute going on in Western lands, and I think people in Canada may have some of the same experience. Some people believe that there's too many wolves. Some people believe that any wolves are too many. Others believe that the species and the individual populations are still in trouble and in need of recovery. Wildlife biologist does tracking of wolves by radio collar. But those kinds of tagging experiments are very time dependent. I mean, wolves move a lot, and so you have to be there when the season is right. And all of a sudden you take a 2-week chunk out of that season. We had other wildlife biologists say, my work was studying the impacts of a major rain event because there was a major tropical storm that moved through the East Coast. My window to study the impact of that increased water flow was the 2 weeks we were shut down. So I lost the entire year. Particularly for ecologists, timing is all for a lot of field work. You can't just sort of say, well, I'll do it 2 weeks from now because the animals are moved or the plants are in a different stage or whatever might have happened in the ecosystem. The same thing is true for agricultural systems. The world doesn't stop because Congress couldn't figure out how to fund the government.
So then what are the ramifications of this?
First of all, inconsistencies, sometimes outright gaps in time series. And again, all of the scientists listening to the program will recognize that if you're doing a longitudinal study or you're measuring things through a time series in the field or even in the lab, you want consistency in measurement through that time series because you don't need to introduce any other statistical artifacts. So when you take a 2-week chunk out of it, you've now introduced some more uncertainty into the basic data stream. For some long-term monitoring systems, that immediately will cause some problems because now you have to figure out, should I adjust for the fact that we either had missing data or it was collected under slightly different conditions, or should I just leave it alone and hope that we haven't introduced any problems into the data series? So that's an immediate long-term impact. All of these data series become important for monitoring everything from plant pathogens to environmental effects to wildlife movement to, in the laboratory, the course of a disease, and so on. There's an impact on the science which potentially causes some problems. In some cases, it's an actual gap. So there's a real question for the Antarctic missions. They're just about coming up to the austral summer, so they're in the midst of sort of high intensity planning and deployment. And all of a sudden they had to stop for 2 weeks. So NSF and other agencies are scrambling to figure out whether the entire field season in the Antarctic, which of course is critical for everything from climate to a lot of other processes. There's biomedical research, lots of things happen in the Antarctic, but is time critical. One of the potential impacts is, gaps in those data series or inability to actually collect data on particular aspects for this field season. There's a long-term impact, I believe, on scientists who are in training, students, postdocs, certainly graduate students. First of all, 2 weeks without being paid is a bit tough when you're on a graduate fellowship. Trust me, I know I have graduate students. I am shocked to find that, my graduate fellowship from 30 years ago wasn't very much less than their graduate fellowships now in some cases. It also delays their work because often people are relying on federal resources for access to field sites, for access to laboratory equipment, for connection to other researchers. And 2 weeks might not seem like a very long time, but if you're pushing hard to try to, complete your research for a graduate degree or for a postdoctoral period that lasts for 1 or 2 years, 2 weeks is a big chunk out of your research effort. For some cases, it's pretty clear that if somebody missed a field season, they're going to have to stay to do another field season to complete their work. That more costs, more expense. So that has a long-term impact. I think a final long-term impact that's really quite important is the impact on morale, not only for young early career scientists who are trying to decide, well, should I go work in a federal laboratory or in academia, but also for senior scientists who are saying, I'm senior in my field, or I'm at the height of my research career. Do I want to stay and work for the federal government if this is, is this going to be a regular feature of what happens? All of a sudden I'm told, pack things up, go home, and then I'm going to have to spend months trying to, recover from that sort of silly hiatus, if you like. So that's a long-term impact too, just the morale of people working in what are critical federal science agencies or connections to federal science agencies.
I feel like we should probably talk about potential hyperbole because some of the comments on your piece were not terribly charitable. And I'm just going to read two of them, both of which I think are fairly representative of that perspective. So the first one said, "Articles like these are the reason I believe that the magazine should consider changing its name to American Quasi-Scientific Inquirer and start distributing in supermarket checkout stands with the rest of the sensational rags with revealing articles about Diana death conspiracies and alien autopsies." Wow. And the other one was, "Oh, come on. The Dark Ages were temporary, and so was the damage to science. This is nothing. Permanent? Ask science in 100 years. As if the USA is the only place that has scientists." So what would you say to those comments then?
Well, to the first one, that's fine that you choose to disbelieve what people within the community are saying, but we were relaying the views from scientists from around the country. And there's all kinds of, sort of dismissive conspiracy theories. We didn't make any of the stuff up. It was directly relayed from, researchers all around the country. And I've heard some of that stuff before, and frankly, if somebody chooses to just dismiss it all because they didn't do it themselves, that's their prerogative. To the second one, unquestionably, there is research going on all around the world. In 100 years, will somebody look back and say, boy, that 2-week window was a real problem? Well, I don't think so, but I happen to have spent some time doing time series analysis, and if you had an inconsistency in a time series, yeah, it could actually cause a problem. But is that really what we want to say? Well, somebody else, maybe somebody in China will do the research. We don't really need to worry about it. It does have an immediate impact, and it does have a long-term impact. Tell the people who were not able to get into cancer trials at the National Institute of Health, this doesn't make any difference, because in 100 years, who will care that you didn't get into a cancer trial? I just think that that's a really myopic view of what these kinds of things do. The point of the piece, and the point I think of the concerns about the shutdown, is that people are minimizing the role that the federal government plays in an enormous number of activities, scientific activities that touch pretty much every aspect of life. Now, some people believe the federal government shouldn't be there and shouldn't do all of this work, but realistically, in our country and in every other developed country, the governmental science enterprise is critical to researchers and to the products that they produce, science and technical products that they produce. You can dismiss those and say, who cares? I don't need any of those products. I'm independent and on my own, but I don't think that's reality.
You mentioned scientific morale. Now, does that extend to the public? Do you think the shutdown might have affected the public's perspective on the importance of those programs?
I don't think so. I think in terms of a positive or negative view of science or scientists itself, I don't think that there's an impact there. I do think that every time something like this happens, the public says, gee, I didn't know that this was connected through to activities of the federal government, and they shouldn't have stopped. I mean, they shouldn't have stopped the product inspections, or they shouldn't have stopped the cancer trials, or they shouldn't have stopped the wildlife field trials, or the hydrology work following on from storms. That's important to me. So I do think it brings people a little bit closer to the role that some of this scientific work plays in their own lives or their own concerns. And that's a good thing. But this is not the way that I would like to raise that consciousness, frankly. We titled this as a very poorly planned experiment to see what happens if you turn off the switch for 2 weeks. And frankly, what happens, I think, is quite profound. The science enterprise of the United States and many other countries is integral to society. It's not just somebody sort of pottering away in a lab somewhere quietly without any connections to the real world. And it's not just people scratching their heads and thinking great thoughts in some dark corner. It's connected to an enormous number of aspects of daily life, which is also why I disagree with the commenters. So we tried that experiment, and what we learned is it does have real impacts, even for short periods of time. It's not the way to proceed. If you decide we shouldn't do particular science and technical activities, make that as a conscious decision, understanding the ramifications, not this kind of sort of blundering experiment.
Well, and as someone who follows science news fairly closely, is it just me, or does it seem like this is just yet another example of science getting caught in partisan crossfire? One of many, really. And not just in your country, mind you.
Yes, I understand that. And I should say that while the U.S. tried this, foolish and blundering experiment, the results should be evident to many other countries that, don't try this at home. It doesn't make a lot of sense. I actually think that there is an increasing trend in science, and not just science, being caught in this partisan crossfire. I mean, clearly the shutdown had very little to do with the science work per se, although you would have to say that, some of the battle was over whether the federal government should continue to fund such a broad range of activities. Okay, that's a societal debate that should be had, but until there's a conscious decision of what we should fund and shouldn't fund, which actually is the responsibility of Congress. The responsibility of Congress is not, binomial. It is, we should come up with the spending plans, and all of this occurred because Congress didn't do what they were supposed to, which is come up with the spending plans. And if you have the votes, and you want to reduce spending and cut out a bunch of scientific activities, that's the way our political system works. This was an aberration, in my view. But we are increasingly seeing science and technical expertise under attack, scientific work under attack, the work of advisory panels under attack for partisan political reasons on, a range of issues. It's not just on climate science. It's not just connected to oil and gas development. It's on a pretty broad range of issues. And science and scientific work never used to be partisan. That's a relatively recent phenomenon. Some people feel, well, it's always been this way. Maybe it's a little worse now. It never was partisan in the United States. There were very strong supporters on both sides of the aisle. for the scientific enterprise. That's why we have built a very large, complex scientific enterprise that plays such an important role in society, because both parties were strong supporters of building that enterprise over the last 40 years. So it's increasing. My program is designed to push back, not in terms of funding, but in terms of the role of science in public policy, which is, at the end of the day, the most important part of this is the science that we use in public policy, private sector development, in people's everyday lives, so citizens can make informed choices. It's the acquisition of knowledge that should be an important, and it always has been, and I believe will continue to be an important driver for societal development. Sounds a bit grandiose, but there you go.
No, I was thinking that sounded glorious, actually. Are there other groups beside the Union of Concerned Scientists that are actively trying to, let's say, separate politics from science?
There certainly are. There are many groups in the United States now, and I believe in other countries, that are thinking about what's often referred to as reinvigorating democracy and improving citizen engagement, which certainly does connect to science. There are other non-governmental groups that are working on different aspects of this problem of science. We are specifically, the Center for Science and Democracy at Union of Concerned Scientists is specifically working to advance the role of science in public policy, to push back against misinformation, to help scientists be prepared to push back against, direct attacks on them or on their work, and to try to bring scientific evidence more strongly into the public debate. And we think the union created this program a couple of years ago, specifically because of concerns that the partisan political debate was pushing science to the side and treating science as a special interest. And, I firmly believe, and my program is based on the idea that, of course, there are a lot of other factors that go into societal choices, but that scientific evidence should always play an important foundational role in public policy, whether that scientific evidence is from social science or from natural sciences. And that, as a politician in the United States, whose late politician Daniel Patrick Moynihan said, everyone is entitled to their own opinion, but not their own set of facts. And so we're not saying you must come to this conclusion based on the scientific evidence, but that it's important that people actually have the scientific evidence available to them.
Well, I think I speak for us all when I say good luck, sir.
I believe we can make progress, otherwise I wouldn't be doing the job.
Andrew, thanks very much for being here.
Thank you very much, Desiree.
And we've linked to Dr. Andrew Rosenberg, the director of the Center for Science and Democracy at the Union of Concerned Scientists, on our website at scienceforthepeople.ca. And we'll be right back for more on science and the shutdown with NASA researcher John Sonntag after this.
Science for the People is a weekly radio show exploring everyday life from a scientific perspective. To find out where Science for the People airs near you, or to listen to past episodes, check out our website at scienceforthepeople.ca. You'll also find links to connect with us on Facebook, Twitter, and Google+, or to subscribe to the podcast in iTunes. And now, back to the show.
I'm joined by John Sonntag. John started his professional career in 1993 with EG&G Incorporated, working as an analyst for NASA's Airborne Topographic Mapper team, and he's now a senior scientist with URS Corporation and the instrument team lead for NASA's Operation IceBridge. Welcome, John.
Thank you.
Okay, so give us some background on Operation IceBridge.
Operation IceBridge was started by NASA back in the year 2009, and the idea was to bridge a gap in satellite observations of the polar ice caps. The gap was created by the demise of the IceSat-1 spacecraft, which was a laser altimeter spacecraft, which was launched in 2003 and ceased operating in 2009. The successor spacecraft is IceSat-2 and is currently scheduled to be launched in 2016. So NASA, seeing the gap in its capabilities to monitor the polar ice caps, called upon existing airborne science assets to bridge that gap in observations of the polar ice caps, and that's what Operation IceBridge is meant to do.
So what exactly is the goal of the project?
It's probably best described in two goals. One is to monitor the changing state of the polar ice caps. And by polar ice caps, I really mean polar ice caps writ large. That includes sea ice, ice caps, outlet glaciers, all kinds of polar ice. So we want to monitor the changes that are currently going on in the ice caps in both North and South, Arctic and Antarctic. But the other thing that we want to do is to collect measurements which will allow us to put those changes into context to determine why the changes are occurring and how they may continue to occur in the future. So the observations that we gather are meant to do both of those things.
Now, you only have a short window in which this operation can run, correct?
Yeah, in particular this operation, that's right. We're doing something new this fall that this is our 10th IceBridge deployment. We do 2 per year starting way back in 2009. And so this was going to be our 10th deployment. And the idea this year, as opposed to previous years, was to take a large wheeled aircraft. And I mentioned wheels specifically because that makes a difference down here. We're basing a large wheeled aircraft, the NASA P-3, at McMurdo Station, Antarctica. And the fact that the aircraft has wheels and not skis limits our window of operations down there to a time when the runway that's built on sea ice is available. Now, along about December 1st, the sea ice gets too thin. It starts to melt, and it gets too thin to support the aircraft, the weight of the aircraft. And so we have to complete our operations by about December 1st.
And I understand this is actually a fairly dangerous operation for the staff involved.
Well, I wouldn't say dangerous. We certainly, it does create the potential for danger, and we've gone to, believe me, great lengths over the last 6 months to mitigate those dangers, to come up with a plan to minimize them, and also we built quite a bit of new technology specifically to address the potential dangers of the mission and bring them down into a level that we all feel very comfortable with.
So now you gather this data, and what do you use it for? What is it generally used for?
Well, the data is used by many, many scientists all around the world. There are really two things going on with the data. One of them is to quantify what's going on with the ice as it is now, to measure the changes that are going on, and to put that in the context of the changes that we've seen over the last couple of decades in the polar ice. And again, that means both the state of the sea ice and the state of the glacier ice, which are very different kinds of ice. So that's one thing that scientists do with the data. But the other thing that they do with the data is to determine the processes that drive those changes. And so to give you an example, one of the instruments that we use is a scanning laser altimeter. And what that does is it measures the topography of the surface of the ice with great detail and great accuracy. And so when we do that, we measure the same bit of ice in successive years. We can look at the changes. How much has it melted or gone up or down in elevation? But another kind of measurement that we take is ice sounding radar. What that can do is measure the depth of the ice and the shape of the bedrock underneath the ice. And the shape of that bedrock, especially in conjunction with sea level nearby, has a great determining influence on the past and future behavior of that ice. So in measuring those two things simultaneously, we both get at what's going on with the ice, what the current changes are, and what may be driving those changes, and what changes may continue to happen in the future.
And are there any other ways to get that data?
Not really. I guess is the best answer to that. You can get some of it via satellites, and that, of course, is what was the idea with ICESat-1 and IceSat-2. To some degree, it's also the idea in the European Space Agency's Cryosat-2 spacecraft. But when you're making these measurements from orbit, you're obviously a lot farther away from the thing you're trying to measure than you are in an aircraft. And particularly a low-flying aircraft, which is what we do. We typically fly about 1,500 feet above the surface. And because you're flying so low, you can take advantage of physics, basically, to let you get a lot more detailed and a lot more comprehensive measurement types. You can get even more detailed and comprehensive measurements when you're actually on the ground, but you can't gather them over a very wide area. So what the aircraft does is it sort of bridges the gap between the surface-based observations and the spacecraft observations.
So how did the U.S. government shutdown affect your project?
Well, it really whacked us, to put it bluntly. We had originally planned to have a field season of just about 6 weeks, 6 weeks of flight operations out of McMurdo Station. And even that was thought to be barely adequate for the task. 6 weeks of operations down there, when you factor in potential aircraft maintenance issues, spare parts, weather outages, holidays, necessary overhead time for training personnel, that sort of thing, the 6 weeks of flight time may only let you get maybe 10 to 12 flights in, particularly if the weather is bad that year. So as a result of the shutdown, we had one of the possibilities, as of literally as recently as 2 or 3 days ago, was that the project would be canceled outright. But a couple of days ago, through Herculean efforts on the part of both NASA and the National Science Foundation, we were told that the project is indeed going to go forward. But the kicker is that we only get about 1 week of flight operations down there, which is not nearly as much as we'd hoped for. But since most of the money is already spent, we all feel the need to get something for our money, but also to prove that this can be done in the manner in which we're doing it, in order to inform decisions in future years on budget and level of effort. We felt it important to go ahead and continue with this project and to go down there and get whatever we can get, even with just a week of flight operation.
Exactly why did the shutdown affect your operations? It's like, how much of the operation is government funded?
All of it is government funded, although the participants are not all government. I am, in fact, a U.S. government contractor. I don't work directly for the government. I work for a corporation. And most of the participants in the operation are, in fact, university researchers, contractors, and a few government people as well. But NASA funds the entire operation, paying all those contractors, paying for the flight time. The aircraft itself is a U.S. government asset. It's NASA. And in addition to that, because we are working on the continent of Antarctica, Antarctica doesn't have any of its own indigenous population, of course. It doesn't have any of its own cities. It has no indigenous infrastructure of its own. And so many countries, including the United States, actually build and operate small cities, what amount to small cities in Antarctica. One of those is McMurdo Station, where we're going. Those are funded by the United States government through the National Science Foundation. So not only was NASA's funding for this mission at risk, but the entire logistics infrastructure for the continent of Antarctica in the United States context was shut down.
Okay, so you narrowly circumvented disaster here. What would the repercussions have been?
Imagine the Antarctic ice cap as a cardiac patient. His life is potentially in danger. Had we not gone on this trip at all, imagine that as that cardiac patient skipping a weekly appointment with his doctor, not going at all. Now, because we can get at least a little bit of a field season, it looks like we are going to be able to get that much out of this year. Now, instead of getting a good solid 30-minute doctor visit, now you get maybe a quick 5-minute doctor visit instead. So it's better than nothing, but it's certainly not what we had hoped for.
That was a horrible but apt metaphor. Thank you. Well, John, good luck with the project. It sounds brilliant. And thanks very much for being here.
I appreciate the time.
And for anyone who's interested in checking out Operation IceBridge, we've linked to it on our website at scienceforthepeople.ca. You're listening to Science for the People. I'm Desiree Schell. My next guest is Dr. Marshall Shepard. Marshall is a full professor in the Department of Geography and director of the Atmospheric Sciences program at the University of Georgia. He's also a member of the Initiative on Climate and Society, Faculty of Water Resources, and the College of the Environment, and an affiliate of the Southern High Resolution Modeling Consortium and a member of NASA's Precipitation Measurement Mission Science Team. He's also the current president of the American Meteorological Society. Wonderful to have you here, Marshall.
Oh, happy to be here.
So on today's episode, we've been covering how different scientific fields were affected during the government shutdown. So how did meteorology fare?
We took our hits, particularly on the operational and the sort of research sides of the house. The National Weather Service, several impacts. They were not able to do routine maintenance of things like weather instruments, radars. I fear that the delays from the shutdown may have pushed back the processing and planning for our next generation weather satellite program, which will be launching in a couple of years. There was already concern that there would be gaps in coverage due to planning and budget. Every week counts as we're trying to get that back on schedule. And then, ironically, as we're approaching the 1 year anniversary of Superstorm Sandy, there were calls for improving our weather models, bringing them up to speed with some of our European counterparts. Many of the very people working on research improvements of those weather models were sent home during the shutdown.
Well, let's get into some specifics. There were a number of websites down and some software affected, right?
Yeah, that was one of the most disturbing aspects for me. More and more people are consuming weather information, warning information from websites and social media. Events like Sandy, the flooding that we saw in Colorado earlier this year, the tornadoes, El Reno, and more tornadoes in Oklahoma. When we have these real-time weather events, social media and websites are quite active with warnings, and I'm convinced that more and more people consume their information there. Many of the websites, for example, the NOAA website, the National Oceanic and Atmospheric Administration website, and their Twitter feed were down. There were other sites that were down as well. So when we shut off conduits of information to the public, I think that actually jeopardizes lives and property.
How does the shutdown of those websites affect weather forecasting?
To be fair, many of the weather forecast offices, some of the more operational offices like the National Hurricane Center, they were still working. But even in those situations, their websites were up. But ironically, many of those colleagues were working on the promise of a paycheck. They were actually not receiving pay. And so although there was a promise of a paycheck, their mortgages and their bills were still coming in. So thankfully, those National Weather Service forecasters and people at the Hurricane Center were operating and working out of dedication for their service and to their country, but not sure that they were going to get paid in some instances. So the operational mission kept going. However, maintenance to some of their equipment and facilities, future upgrades to their models and capabilities that may have an impact next year or in next year's hurricane or tornado season were affected.
Well, and with every other research field, I know that research was affected. So did we see that within monitoring and collection of data within meteorology?
I think the biggest impacts were on people that are working on improvements to our weather forecast models and some of our other technology. These people were sent home. For example, Senator Barbara Mikulski from Maryland actually brought forth a researcher that was working on a next generation storm surge model that, as we saw in Sandy, many people died from surge and inundation. So we are advancing new capacity with our storm surge models. We're developing new capacity for improving our day-to-day weather prediction. Many of those people were not there. Also, much of the research that goes on in academia finds its way ultimately into the operational community, places like NOAA, National Weather Service in this country, or NASA. Many of my students, many of my research projects, and many of my colleagues' students and research projects were impacted. We actually had to shut down certain research projects because we could not access data from certain federal websites, and that was a travesty.
And let me guess, the information that wasn't gathered during the government shutdown is now totally unretrievable by any other means?
I think some of it would be available now, but there were certainly some. I did a show here in the United States on a sort of similar radio program, and we had one researcher who does research down in the Antarctica that mentioned that there were actually data sets that were not being collected during the shutdown that could impact the overall record, sort of the viability of the data record that he uses in his research. In our case, on the weather side, many of that data was just not accessible because the databases and the websites that house these databases were just not accessible. So some of the weather software that some of our TV forecasters use, something called BuffKit, for example, was having trouble accessing some of that data. We were having trouble accessing things like census information, climate information that's utilized not just in research, but also in reporting of weather and climate records. So those types of things, although they are likely back up now, had an impact when the shutdown was in real time.
What if there was a severe weather incident during the shutdown, like a massive storm somewhere? Would the shutdown have affected response time?
That's an interesting question. I think some people rely on certain websites and Twitter feeds that were down, so they may have certainly been impacted. Also, FEMA, the Federal Emergency Management Agency here in this country, they are the first to respond to weather hazards, things like hurricanes or massive blizzards that affect the populace. Many of those people were at home because of the shutdown. Now, interestingly, during the shutdown, it looked as though we were going to be affected in the United States and the Gulf of Mexico by Tropical Storm Karen. And so they actually called some of these people back, but there is a time lag by which some of these people can get back to work and get in places that they need to be. So I think there would have been impacts on response had there been a major event. At a minimum, many of those people would have been called back to work but would not have been paid. So that's still an issue in its own right. Just heard something recently, again, related to the fact that you couldn't get routine maintenance of some of the National Weather Service instrumentation, their radars, their computers. That could certainly have an impact if there was sort of a gremlin or sort of a sustained problem with some technology or instruments, and there's a major weather event, and all of a sudden the computer breaks. That's not good.
Now, you wrote a blog post about the impact of the shutdown, and there was something that I found really interesting that I hadn't thought of before. How shutdowns potentially cause some students to want to avoid working in the federal sector at all.
Yeah, there's a screaming message to our students and our early career professionals. Typically, before I joined the University of Georgia, I was a scientist at NASA for 12 years working on weather and climate missions. Typically, NASA, NOAA, EPA, Department of Energy, FEMA, these are desirable places to work. But increasingly, in talking to young professionals and students, they're becoming more leery of working in the federal sector. And so are we going to be losing some of our best new talent because they're fearful that they're going to be kicked out of their jobs occasionally or will not be able to travel to scientific conferences? One of the things that happened during the shutdown, the National Weather Association, which is a similar but smaller organization to the American Meteorological Society, was having their annual conference in Charleston, South Carolina. Many of our National Weather Service and academic colleagues, as well as TV broadcasters, attend that meeting and share best practices, learn new knowledge, learn new techniques that can be put into practice. Most of our National Weather Service meteorologists and forecasters were told they could not go to that meeting because of the shutdown. And so that's something that we can't get back.
I was wondering about the research. What kinds of research are done federally compared to what those students would be doing in the private sector?
Well, students are actually working in the private and the academic sector. Here in the United States, our weather enterprise is basically a third academic, a third private sector, and a third federal sector. And there's a partnership. It's not just sort of stovepiped into those areas. These three areas work together on research. Many of the advances that we see in our predictive skill, our weather models, our new radar systems, our new satellites have come from collective and partnerships amongst academia, private sector, and the federal sector. So it's really difficult to parse out contributions. So in general, all of them were affected, even the private sector, because one of the things that many of your listeners may not be aware of is that even when a place like NASA, a research lab at NASA or NOAA, sends home its federal researchers, many of those federal researchers are supported by private sector scientists that are contractors to those federal agencies and research labs. And so they oftentimes are sent home as well. Many of our weather satellite programs here in the U.S. are not just being developed by NASA and NOAA. Many large private companies are involved in that process too, and they're directly and indirectly affected by these shutdowns as well. So it has a trickle effect that's much broader than just the federal sector.
Marshall, thanks very much for being here.
Thank you for having me.
You can find Dr. J. Marshall Shepard at the link on our website at scienceforthepeople.ca. And we'll be back to wrap up our hour on science and the shutdown with Casey Dreier, Advocacy and Outreach Coordinator for the Planetary Society, after this.
On the next episode of Science for the People, we'll speak to a trio of online experts for a look at the lighter side of science. Desiree Schell welcomes favorite guest Cy Curious to talk about the 2013 Ig Nobel Prizes. Rochelle Saunders speaks to researcher and blogger Derek Lowe about the chemicals that he refuses to work with. And we're joined by online video veteran Zay Frank to talk about his True Facts series. That's next week on Science for the People, on your local radio station, or online at scienceforthepeople.ca.
This is Rochelle Saunders, and I'm here with Casey Dreier. Casey decided to devote his career to furthering the cause of planetary exploration after witnessing the launch of MSL Curiosity on November 26, 2011. It was that kind of experience. As Advocacy and Outreach Coordinator for the Planetary Society, he helps craft and implement the Society's advocacy efforts in Washington, D.C. to further the cause of solar system exploration. Thanks for being here, Casey.
Happy to be here. Thanks.
Now, we invited you to the show to talk about MAVEN, NASA's next mission to Mars.
Yeah, so MAVEN is a mission, it's an orbiter to Mars. So unlike Curiosity, it's just going to stay above the surface. And what it's going to do, it's going to sniff the atmosphere, basically, and it has a variety of complicated instruments that I don't understand how they work, but effectively what it's going to do is to try to determine what happened to Mars's atmosphere. Right now, Mars has this very tenuous little atmosphere, about 100th as dense as Earth's atmosphere. But way back in the past, we think Mars's atmosphere is more like Earth's. And so what happened to it? That's the main question that MAVEN's going to go after. Right now, Mars's atmosphere is so thin, the pressure on the surface is so low, that you can't even have liquid water, for example. It would bubble away, boil away instantly, and then freeze because it's very cold. But back in the day, the atmosphere was thicker. They think it could have held liquids at the surface. Maybe it was a lot warmer at the surface. And so something major happened to Mars.
So how do we know, or why do we suspect maybe, that Mars used to have an atmosphere closer to Earth's?
Well, we know it was thicker, for nothing else, that we know liquid water used to exist on the surface of Mars. These are all the channels and dry river valleys that they see from orbit. And then also the Curiosity rover has actually detected mudstone and other minerals that could only form in water. So again, because water boils now at current Mars atmosphere pressure, we know it had to be thicker to support this liquid water at one point in the past. And then we also have more advanced data by looking at what's called argon isotope ratio. So argon is an element that doesn't do much, it doesn't react chemically with anything. And it has two types of isotopes. So one, a little heavier, it has some extra neutrons. We can look at the ratio of those. And we know from observing the atmosphere of Jupiter and also of the Sun, what this kind of basic default ratio between these two argon isotopes should be at the formation of the solar system. And so Mars doesn't have the same one. It has a different ratio of argon. The lighter argon isotopes have actually been stripped away. It's missing from what it should be.
That means that something took it away with the rest of the atmosphere. And that's one of the ways they know in which the atmosphere used to be thicker, because of this missing argon.
That sounds pretty cool. When is that supposed to launch?
That launches November 18th out of Florida, and it'll take about 9 months or so to get to Mars.
So in the article I read about MAVEN, before the government shutdown ended, the writers were concerned that MAVEN would actually miss its launch opportunity. Can you explain that a little bit?
You have these orbital mechanics of how and when the planets are kind of aligned or far from each other. You have these ways to reduce the amount of energy. You have the least amount of energy possible to get to Mars by launching at very specific times among the Earth's orbit when it's aligned up with Mars. You want to do this because launching things into space is really expensive, and the heavier something is, the more expensive it is to send out into space. And it gets to a point where we don't even have rockets big enough to send something to Mars if we're in the totally wrong orbit, where it would take extremely long amounts of time. Do you have to swing by the sun? Or, we just want to get to where we're going, because every day of a mission costs money. Every extra pound on a mission costs money. So you want to have as little propellant as possible, and you want to speed up the mission as much as you can. This is the concept of what they call launch opportunities. Every 26 months, there's an opportunity to launch to Mars in this really low energy configuration that takes about 9 months. Because of this, you can't launch to Mars last year. You can't launch to Mars next year. You can launch to Mars in this little opportunity that's coming up in November. And it lasts from this launch position in Florida, I think about 3.5 weeks. And so if you miss this opportunity, you have to wait 26 months to launch again in 2016.
So that's a pretty narrow window. Was that window threatened with the government shutdown?
Yeah, it was, because when the government shut down, MAVEN shut down too. So right now, MAVEN has been built. Lockheed Martin built it in Denver, Colorado. And they had shipped it a few months ago down to Cape Canaveral in Florida. And they were getting ready to launch it. So what that means is that they reassemble it, they get the solar panels on, they do all these final last-minute checks of the electronics and the hardware to make sure it's all working. They get the rocket, they have to prepare it, test it, load it full of fuel. It's a lot of stuff to do. And so they were busy preparing for this launch in Cape Canaveral. When the government shut down, all of that launch preparation stopped. And again, you only have this little opportunity to launch to Mars starting November 18th. If you don't hit that opportunity, you don't launch to Mars. So every day the government was shut down initially was a day lost to prepare the mission. The mission had some time buffered in, just in case something went really wrong in the spacecraft. So they were able to absorb some of this. But at the very beginning, it was a definite possibility that this could have major implications to the mission.
So how many people are we talking about here, and how much preparation goes into something like launching MAVEN?
You have all kinds of flight technicians and engineers and people kind of building and preparing, overseeing the spacecraft. You have hundreds of scientists kind of involved. You have the principal investigator ideally keeping tabs on how everything's going. You have NASA managers, but fundamentally, I'd say hundreds of people down at the Cape.
And how long have we been prepping for MAVEN?
MAVEN was a mission under what's called NASA's Mars Exploration Program. So you have this office within NASA. It must be this very cool job to think about how to send spacecraft to Mars as much as possible. That's their job. So they had this program called Mars Scout. Basically, it was a chunk of money set aside for missions to Mars within a certain cost limit. So basically cheaper missions to Mars. So I don't know if you remember Phoenix. It landed on Mars in 2007, really up close, far up north next to the ice caps, and dug and found ice. That was a Mars Scout mission. That was the very first one. Then in 2009, they selected another Mars Scout mission, and that was MAVEN. So MAVEN was selected. So basically, bunch of scientists competed for these ideas, and they all said, I have the best idea for a mission to Mars. No, I do. And no, I do. And they put together these detailed proposals, and MAVEN was selected out of that in 2009. They spent the last couple of years building it, and now they're going to launch.
If MAVEN missed the launch, the next opportunity would be when again?
2016, so about 26 months from now. This actually happened to Curiosity. Curiosity was originally planned to launch in 2009, the 2009 Mars launch opportunity. But there were some major technical problems that Curiosity had. They had to redo a whole bunch of engineering stuff at the last minute, and that made it so that there's no way they could have made this 2009 launch possibility. So Curiosity was delayed 2 years. That added hundreds of millions of dollars to the mission, because you basically have to retain a standing army of engineers and scientists and mission specialists and program managers for another 2 years. That in itself adds millions and millions of dollars. Even though this was selected in 2009 to be developed into the next mission, this is an idea that most likely had been bouncing around for years beforehand, and the people trying to get this selected for many years. And so this mostly likely represents a lifetime of work for a lot of scientists on this team. And if it missed, who knows what would have happened. There's really bad kind of budgetary pressure on planetary exploration at NASA right now. No one knows where they would have gotten this money from to keep this mission, on the shelf for 2 more years. It would have been a very difficult situation.
I can't imagine the mood at the MAVEN project at NASA was really great during the shutdown.
I imagine there were some tense moments, but don't forget, and we have to emphasize to everyone listening, this does have a happy ending. Work on MAVEN to get it ready for launch actually began before the shutdown ended. Now, how did that happen? So the shutdown first happened, MAVEN went dark, and people started to freak out a little bit, I think naturally. So people on the team, you have people in NASA, those who were allowed to work. And then you also had, I was writing about this, other scientific journalists were writing about this, basically saying, what's going to happen here? This is crazy. You can't let this happen. And then ultimately, probably the most importantly, Senator Bill Nelson from Florida, a big space supporter, wrote a letter saying, oh, by the way, I'm very concerned about if MAVEN's going to be able to launch in November, to the White House, basically. And a few days later, they found a reason to keep MAVEN going. And so during the shutdown, not everyone in the government had to go home. There were these things called accepted programs. Anything that supported existing property protection or protection of human life, people would still come and work for that even while the government was shut down. They wouldn't get paid to do this, but they would be allowed to do it. Because government workers, they weren't even allowed to volunteer their time in the shutdown. They were forbidden from doing any work. And so you had a variety of old laws saying that, you have exceptions for these situations where protection of property or life. So, for example, hundreds of people at NASA were allowed to continue working to support the astronauts on the International Space Station. So right now we have 2 rovers on the surface of Mars, right? We have the Curiosity rover and we have the Opportunity rover. We're building another rover to launch in 2020, which is very creatively named right now the 2020 rover. and and we also have a lander in 2016 called InSight. We have so many things on Mars right now that they send back so much data, they collect so much data that sending it back is actually really hard. This is a weird bottleneck in our technology. Curiosity can talk directly to Earth, but it can do so relatively at a pretty slow pace. I forget the exact number, but it's not very fast in terms of data speed. It's a lot faster for Curiosity to wait for the Mars Reconnaissance Orbiter spacecraft to fly overhead and send its data to the satellite. The satellite has a huge antenna, and the satellite will then send that back to Earth. So we have this, it's kind of cool. We have a communications relay system around Mars, which is one of the most futuristic sounding things that I can think of. And so that helps us send back enough data. Curiosity sent back hundreds of gigabytes of data right now. You could not do that if Curiosity was just talking to Earth directly. It'd be far less. And so you have this real issue with there's collecting so much data on the ground. How are we going to get that data back to Earth in a timely fashion? So right now, the heavy lifting is done by the Mars Reconnaissance Orbiter and Mars Odyssey. These are 2 spacecraft that were sent to Mars to do high-resolution imaging and other scientific measurements of the surface from orbit. And they also then filled this gap of being a communications relay for anything on the ground. Mars Odyssey got to Mars in 2001. Mars Reconnaissance Orbiter got there in 2006. These are aging spacecraft. They're probably not going to be around that much longer. And because of that, MAVEN, when it was designed, they added in this special type of communications transmitter to communicate extremely fast with any ground-based landers or rovers. So MAVEN is this essential kind of backup communication system for rovers on the ground. And that's how NASA was able to argue and say, look, getting MAVEN off the Earth during this launch opportunity is crucial to our ability to support our current property on Mars, the ability to run those missions. And that was kind of the magic way that they were able to argue that they can prepare the mission for launch during shutdown. It's kind of funny that they didn't think of this before, but they figured out a way to make it work. So, I mean, this is a long way of saying it. They had to find a reason to fit in with an existing law, and they found that reason. And luckily they did, because the shutdown lasted over 2 weeks. That would have been really hard. That really put a lot of pressure on the mission. But effectively, MAVEN was only shut down for about 4 or 5 days.
So did the shutdown have a lasting impact on this project?
The shutdown was actually pretty forgiving to most active missions in general, but particularly with the Mars missions. MAVEN looks like it's going to be okay. They're still planning to launch on the very first day of the launch opportunity. That's November 18th. That's a Monday. So that hasn't changed. So it looks like everything is on track.
Casey, thanks for being here.
Happy to be here. Thanks.
And you can find a link to Casey Dreier and NASA's MAVEN on our website at scienceforthepeople.ca.
And in case we haven't depressed you enough, I should point out that the current budget bill expires on January 15th. The only thing that will save the U.S. government from another shutdown is if their politicians learned a lesson from the mess they made this time around. I think it's safe to say we're doomed. Thankfully, I do have a bit of more hopeful news to end on. This year, I'm proud to once again serve as a judge for 60 Seconds Science, the international science video competition. 60 Seconds Science invites people from around the world to create a short video that explains an invention, an experiment, a science concept, or an idea, and it's open to amateurs, professionals, and students at every grade level. The deadline to upload an entry for this year's competition is right around the corner. If you're signed up to compete, you do need to upload your video by midnight GMT on Wednesday, November 20th. That's 7 p.m. Eastern and 5 p.m. Mountain. And if you're not registered, well, you've got 12 months to get ready for next year. You'll find links to 60 Seconds Science and all of this week's guests on our website at scienceforthepeople.ca. While you're there, click the links to connect with us on Twitter, Facebook, and Google+, and to iTunes, where you can subscribe to the weekly podcast and support us by leaving a flattering review. Thanks for listening, and we'll see you next week on Science for the People.